This video is going to cover the measures of inscribed angles, as well as talking a bit about central angles and their measurements, because they're very related to each other. This is learning target 4. I can find the measures of inscribed angles and their arcs. So first, let's talk about what it means for an arc to have a measurement. Arc measurements are going to be the same degree as their central angle. So arcs are also measured in degrees as well. In this example you see right here, I have an angle of ACB. And this angle ACB is 65 degrees. And this means that the arc AB is also 65 degrees as well. What this means is that central angles and arcs are always equal to each other. So, given a situation where we have a circle that is divided into many central angles, it's important to make sure that you realize what is equal to what. If I want to use this circle and find the missing degrees of that angle, which is the question mark, I just have to look at the central angles across from the arcs they open up to. So the angle I want to find opens up to this arc right here. The arc is 55. That means that the angle is also equal to 55 degrees. Why are the other degrees here? They are just distractors to make sure that you are looking at the right and appropriate part of the picture. What is the measurement of arc IGJ? So let's see what this picture has given us. This picture has given us many different central angles, as well as one measurement of a central angle and one measurement of an arc. I through G all around the J would be all of these pieces together. Now I don't have all these pieces, but I could figure them all out. One way to approach this is to say that the arc I want to find is almost everything except for this JI arc. So it doesn't include that, but it includes everything else. So if I could find the right number that goes here and subtract it from 360, I could get my answer. So this angle right here with the 116 make 180 degrees. So I can take 180 minus 116 and get that second angle. Since this is a diameter line, and I know that half of the circle, which is what the diameter is on, is 180 degrees. I come up with an angle of 64 degrees. So that is the arc that I'm going to take out of 360 to get all the yellow part of the circle. So 360 minus 64 is 296 degrees. So the measurement of arc IGJ is equal to 296 degrees. Inscribed angles are angles that are not connected to the center of the circle like our last examples. These are angles whose vertex is actually on the circle. They are not equal to the arc. They are actually half of the arc. So that means whatever is right here, I have to divide it by 2, and I get the inscribed angle. Let's take a look at an example. I have 20 degrees for my inscribed angle, and I want to know the measurement of EF. So I'm going to work backwards. I'm going to times by 2, and I will get that angle. 20 times 2 is equal to 40. So the measurement of EF minor arc is 40 degrees. What's the measurement of H, L, J, and J, K, H? In this picture, I have an inscribed angle. Let's talk about this a little bit because there's a lot going on. First off, I have an inscribed angle here that follows back to to L and to H. But that same arc also follows back to K as well. So what this means, this arc can be used to figure out either of these inscribed angles. To get either of those angles, I'm going to divide it in half. Remember that the inscribed angle is always smaller than the arc, so I have to divide it by 2, not times it by 2. I end up with 50 degrees. And this would be the answer to both of them. So the measurement of HLJ is 50 degrees, and the measurement of JKH is also 50 degrees. Sometimes you have to do a little extra work to work around a circle to finally get to your final answer. What information has it give us that we can use? We're given an arc from B to C, 146 degrees, and we're given an inscribed angle of 60. This arc from B to C does not connect back to some other inscribed angle, so I'm not going to use this right away. But I do have an inscribed angle, which means I can use it to find an arc. The arc is always bigger than the inscribed angle, so I'm going to multiply it by 2. I get 120 degrees. From D to C is 120. From C to B is 146. All the way around the circle is 360. Since I have 2 out of 3 arcs, 1, 2, 3 arcs, I can subtract those 2 arcs out of 360 and get my answer. I got 240 degrees by subtracting 120. Now let's subtract 146. I get 94 degrees. Okay, our last example. What are the degrees of the indicated arc? So that's this question mark right here. What information have I been given? Well, if I try to follow this 76 back to an inscribed angle, I would follow it back towards Z. But Z is not helpful to figure out our question mark. So what does our question mark connect to? Let's follow it. It goes up to Z from Y and to D from Y. That would be ZD. Is there anything special about ZD, and what is it given to me? Let's find out. From Z through D to X is on the diameter, so it's half of the circle. That means that together they're going to make 180 degrees. That means if I can take 76 out of 180 degrees, I'm going to get the arc, the green arc, of DZ. I got 104. Now, to get our inscribed angle, we take that arc, we divide it by 2, and we have our answer. 52 degrees. And that is my answer. So what have we done? We have just covered Learning Target 4, which means that we finished our foundational learning targets 1, 2, and 3, the naming and identifying. We're starting to find missing pieces, missing angles and missing arcs of pictures. So we're starting to work on level 3. Do you know that Learning Target 4 will be quizzed with Learning Target 5 and 6 in the future? If you have any questions, make sure you call me over. Don't forget to hit the submit button if you're watching this from your computers in class.